Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is maximum performance of a team. You are given two integers n and k and two integer arrays speed and efficiency. Speed and efficiency both of length n. There are n engineers from 1 to n, and speed of I and efficiency of I represent the speed and efficiency of the I engineer respectively. Okay, choose at most k different engineers. At most k different engineers out of n engineers to form a team with the maximum performance. To get maximum performance, so the performance of a team is the sum of their engineers speeds multiplied by the minimum efficiency among their engineers. Multiplied by the minimum efficiency among their engineers. So the performance of a team is the sum of their engineers speed multiplied by the minimum efficiency among their engineers. If we choose some three engineers, some three k engineers, then we want to calculate the performance by adding up their speeds along with multiplied by the minimum value efficiency. So return the maximum performance of the team. Since the answer can be a huge number, return it modulo of 10 power 9 plus 7. So let us go through this example and get some idea about this. So here we can choose it by greedy manner. We can choose this by greedy manner. Either we can choose this. Here the brute force solution it may go up to n into k, where for each and every index we will choose k elements, and we will try to maximize and see. It may not go in n into k, it may go cubical also, because n into k into that we have to find the minimum element as well on the go. So it may cost efficient. So how we can optimize the solution in a greedy manner? We can use a priority queue, that is whenever a pair of speed and efficiency is not needed, if that is going to reduce our if that is going to increase our priority queue size, which is greater than k, then we can pop the not needed element. We can pop the not needed pair and include the current pair such that it maximizes our optimal correct answer. Now optimal correct performance current performance of engineers. So how can we do that is, why we are using priority queue? The priority queue is best way that it can maintain the elements inside it in either increasing or decreasing fashion based on their min heap or max heap. So each and every time when we want to increase our efficiency, increase our performance, such that we can maintain only size of only engineers of k size. So whenever an extra engineer comes in, we can pop the not needed engineer such that the current engineer can make a better performance answer. So that only we are making use of this priority queue. So let us go through this example and then we can try to find it. If this is our example, right? This is the example. Let us try to go slowly. Let us try to put 2, 5 in our priority queue first. whenever we insert how we are going to calculate the performance, we will be summing up their speeds and we multiply with the minimum efficiency. So as per now the performance is 10. So we can move forward. The priority queue size is k. It has not reached k, so we can just go forward. We can insert 10 comma 4 10 comma 4 10 comma 4. So the performance is nothing but sum of their speeds, 10 plus 2 which is 12 into 12 into. So the current performance for this will be 10 plus 2 which is 12 into the minimum of their efficiency which is 4. Minimum is 4, so 12 into 4 which is 48. And while moving forward we will tend to insert this 3 comma 3, but the 3 comma 3 is greater than the priority queue size because only 2 is allowed, at most two engineers. So we have to pop this out. Whether what we can pop this out, 3 comma 3 we have to maintain in such a way that this performance is not getting reduced. So if we add 3 comma 3 if we add 3 comma 3 with this 10 comma 4, then it is nothing but 13 into minimum of that is 3. 13 into 3 which is 39. So 39 is reducing this 48. So we cannot add this 33 comma 3 into our answer, into our priority queue. Why so? Because when we add 3 comma 3, this performance is getting reduced. So we cannot add this into our priority queue. Let us go forward and we can try to add this 1 comma 9. While adding this 1 comma 9, this we can pop this 2 comma 5 and we can try to add this 1 comma 9. 1 comma 9, if we add 10 plus 1 which is 11 into this 4, 11 into 4, the minimum of the efficiency 11 into 4 which is 44. Even this 44 is tending to reduce the efficiency, so we cannot add this 1 comma 9 as well. We can try to add this 5 comma 7. If we pop this 2 comma 5, we can try to add this 5 comma 7. So the performance now is 10 plus 5 which is 15. 15 into the minimum of this efficiency, minimum is 4, so 15 into 4 which is 60. Now our maximum performance is 60 as per now. So let us try to add 8 comma 2. If we pop this 5 comma 7 and we can try to add 8 comma 2, this may lead to 10 plus 8, 18 the minimum of efficiency is 2, so 18 into 2 which is 36. It may tend to reduce this performance. So our maximum performance that we can obtain is 60 and it is our optimal answer. So how we are actually doing this, how this priority queue is helping, and but on the go we actually want to take the minimum of those values. How we can keep track of this minimum values? So that is going to be a tedious process because that is the main key here, because how we cannot pop each and every element inside our priority queue and check whether this is the minimum or not. So what we can do is we can have some type of sort of data structure that can sort them in increasing order of this efficiency, increasing order of this efficiency, or sorry, yeah, we cannot say it as increasing order like this, because when we are here we have actually want, if we this three, all the three are included in our priority queue, then the efficiency 2 is only included. So what we can do is we can sort them and then reverse it, we can reverse sort them and include in our some data structure vector, such a way that we can maintain the, we can calculate our efficient, our performance by multiplying with this current efficiency, as this is minimum, since it is in some sorted fashion. So what we can do is we can just pair them and we can sort them. So let us try to do 10, 3, 1, 5 and 8, and here it is 5, 4, 3, 9, 7, 2. This is efficiency and this is speed. So we can try to sort them. This 2 and 8, and then 3 comma 3, 3 comma 3, then 4 comma 10, then 5 comma 2, then 7 comma 5, then 9 comma 1. So like this we can sort them in our fashion, but as I said before, we have to multiply with the minimum value of the efficiency. So if this is in this order, we cannot multiply on the go. So what we can do is we can just reverse now. How we can reverse, I will do here, reverse sort order, efficiency and speed. So which is 9, 7, 5, 4, 3, 2, 1, 5, 2 and 10, 3, 8. So actually while I am doing dry run, you see that the minimum value of the minimum value of the speed is popped, and then I am calculating the performance, So so what we are doing is we are going to have a priority queue which is representing a min heap. So we can make use of this min heap, and what we can do is we can insert the elements, that is speed, into the min heap, and whenever the size of the min heap is greater than k, we can pop that element, and then while we can update our answer as max of answer comma the top value of min heap, the top value of min heap is subtracted with the speed. So the speed, we can calculate the performance as the current sum star the current elements efficiency. So like this we can update our answer equal to max of answer comma this. So this is our total algorithm. Let us try to summarize this and try to run our code. First we can declare a priority queue of min heap. Priority queue, how we will declare a min heap? It is in vector of in greater in. So this will give us a min heap. So to store speed, that is our catch here. Actually we are storing the speeds in our min heap, and we have to reverse sort based on efficiency as we want to calculate performance. We need minimum efficiency at each iteration or loop or flow of the program. So So we tend to sort and reverse based on the efficiency. So this is what we are doing is, so let us try to have a vector of as in comma in. This is going to store my this is going to store me the engineer data. So this engineer data is how it is stored. It is stored by efficiency comma speed. Like this I am going to store. So for int I equal to 0, I less than n, plus plus engineer data dot pushback of efficiency of I comma speed of I. So now we have to reverse sort them. Reverse sort based on efficiency. So first we can sort it. Sort engineer data dot begin comma engineer data dot end. After that we can do a reverse, but what we can do is now we have to reverse it. Reverse of engineer dot begin comma engineer dot end. So we have sorted it and then we have reversed it. So this will be reversed and sorted based on their efficiency. Now we can have a int answer variable which is 0 initially, and finally I am going to return the answer mod the given mod value. So we also need a constant mod which is nothing but 1 e9 plus 7. So this is it may go, it may cross, it may give a huge number. We want to do the modular value. So now we will go through all the data in my engineer data. What I will do is first I will get the int efficiency is nothing but data of 0, int speed is nothing but data of 1. So now I have the efficiency and speed. First, whenever I enter into this loop, I will insert this current speed. Min heap dot push of the speed into my min heap. So and I will check whether my min heap dot size is greater than k. If it is greater than k, I can pop it. Min heap dot pop. But what I want to do is I want to calculate the performance, but the performance formula is sum of the speeds in multiplied with the minimum value of the efficiency. So we have to have a variable sum which is going to calculate the speed, sum of the speeds. So sum plus equal to the speed, the sum plus equal to the speed, and whenever the min heap size is greater than k, we are going to pop that element, so pop the print element. So whenever we pop this print element, we want to subtract also, so subtract the min heap dot top. So after subtracting the min heap dot top, we can pop that element. So after which we can update our answer. How we will be updating our answer? The performance formula is nothing but sum, the total sum of the speed multiplied with the efficiency, minimum efficiency. Minimum efficiency we have that in reverse ordered order. So the current efficiency is actually minimum value only. So we can just apply the formula sum is star efficiency. So finally we will be returning the answer mod, that mod value. So let us try to run our code and see. Okay, what is also the currently the efficiency is not if I have made a mistake. Yeah. Okay, let us try to run our code. Oh, data of 0. Why? What happens? Okay, I cannot access it as 0. It is dot first and dot second. Sorry. Okay, now let us try to run our code. Oh, we got exact answer. Let us try to use the example test cases as well. So it got accepted with our example test cases. We get correct answer. So let us try to submit our code as well. Okay, actually we are running into some runtime error. So let us figure it out. Okay, it is cannot fit into the integer value, so let us have it as long and c, because it cannot fit into the value. So if we use a long value, it may be easy for us also to fit in the integer value. So what we can do is finally we can typecast when we calculate it. So now we can try to run our code. Let us try to take this example test case as well and try to run whether it is getting accepted, then we can submit our code. So we are getting some wrong answer. Let us figure it out. So let us actually this is long, so we can just type take the mod value and run the code now. So it got accepted. So let just typecasting issue. So hope this will get accepted. Yeah, it got accepted. So hope you like this video and let me know in the comments if I am able to deliver it properly. I welcome the suggestions as well. So hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.